Good morning, students. In the previous class, we have been dealing with the first chapter, which is number system. And in number system, we have come across two types of numbers, rational numbers and irrational numbers. So let's just revise these before going on to the next topic. Now we have seen that rational numbers are all those numbers which have terminating decimal expansion and non-terminating repeating decimal expansion, right? And irrational numbers are all those numbers which have non-terminating, non-repeating decimal expansion, right? Now, keeping this in mind, let us look at the first example. This is 1.345. Now here you can see that none of the numbers after the decimal point are repeating, and also the number is finishing or stopping or terminating after 5, which means there are no more numbers after 5, right? So what type of decimal expansion is this? This is terminating decimal expansion, right? So this is a terminating decimal expansion, which means this is a rational number, right? Now let's look at the next example. So my next example is 1.3456, 3456, 3456, right? Now looking at this example, we can see that the numbers 3456, 3456, 3456 are repeating, right? So since the numbers 3, 4, 5, 6 are repeating, what can I do? I can write this number as 1.3456 bar, okay? As you can see, this bar represents that this sequence of numbers, that is 3, 4, 5, 6, is going to keep on repeating, okay? So that means we have got a repeating type of decimal, right? So that means 1.3456 bar is what kind of number? It is a non-terminating repeating decimal expansion, right? So what is the decimal expansion of 1.3456 bar? It is a non-terminating repeating decimal expansion, right? So since it is a non-terminating repeating decimal expansion, we can say that this number is an rational number, right? We can say that this number is a rational number, right? Now, the next example we have got is the number 1.345673, 45683472, etc. Now, the etc. at the end of the number signifies that this number is having a non-terminating decimal expansion, right? And as you closely observe the number, you can see that none of the digits are repeating. None of the group of digits are repeating. Here, 3 comes here, 3 comes here, 3 comes here, but none of the other digits are repeating. For example, 3, 4, 5, 6 is there and next comes 7. Here again 3, 4, 5, 6 is there, but it comes 8, not 7, right? So that means none of the numbers are repeating in a sequence. So what is the type of number? So the type of number is non-terminating, and as you can see here, no number after the decimal point is repeating in a sequence. As you can see, no number after the decimal point is repeating in a sequence, and therefore we can say that this number is a non-terminating, non-repeating decimal expansion. And since it has a non-terminating, non-repeating decimal expansion, we can say that this number is a irrational number. So we can say that this number is an irrational number, right? Now let's look at the next thing. Now, the next thing that we're going to study is how to represent an irrational number on a number line. So, two things that you need to notice in this portion is what are irrational numbers. The irrational numbers that you know are numbers with non-terminating, non-repeating decimal expansion, right? And I've already taught you in the class that we can find irrational numbers by taking the root of every number, right? So, how do we find? We can take the root of every number. Root 1 is 1 itself, so it's not irrational, right? Then we can find root 2, root 3, root 5, root 7, root 8, etc. All these are irrational numbers, and we have seen this in the class already, right? Now the next thing that we need to notice in this portion is number line. Now let's refresh our memory of what a number line is. So a number line is a line with 0 as the midpoint, and we can represent every number that exists in the number system on a number line, right? So all the positive numbers lie on the right side of 0 and all the negative number lies on the left side of 0, right? And all the numbers are placed at equal distances, right? Now let's see that once. Let's look at the number line carefully. As you can see, all the equal distances and the numbers are also placed at equal distances, and it continues, right? It does not stop at 3. Here equal distances 0 to 1, the same distance is 1 to 2, and 2 to 3 is also the same distance, and as you can see 1, 2, 3, etc. all the numbers will be represented on this side, all the positive numbers, and it does not stop at 3, it continues on. That is what this arrow shows. This arrow shows that the number line does not stop here, it continues, right? So likewise, let's look at the negative numbers that are on the left hand side. At equal distances again, and the numbers are -1, -2, -3, -4, etc. and it continues, right? So this is what a number line is, right? And as you can see, it is clear that the distance between any two numbers on a number line, any two integers on the number line is 1 unit, okay? So the distance between any two integers on the number line is 1 unit. Likewise, we can see that 0 to 1, the distance is 1 unit. Same distance, 1 unit is from 1 to 2, then from 2 to 3 is also the same distance. Likewise, here also 1 unit, 1 unit, 1 unit, 1 unit, and it continues, right? So now on the number line, not just the integers are represented. On the number line, as I've said before, every number can be represented on the number line. As you know, this is here we have many numbers in between 2 and 3. There are infinite numbers between any two numbers. We have studied it in the class already, right? So I can represent 1.1 here, 1.2 here, 1.3 here, 1.4 here. I can represent 1.12 here, 1.13 here, 1.14 here. So likewise, there will be a lot of irrational numbers as well in between them, right? So lots of irrational number and rational numbers lie between any two given numbers, okay? Now, keeping these things in mind and keeping in mind what a number line is, let's see how we are going to represent an irrational number on a number line, okay? Before starting, we need to know what Pythagoras theorem is, okay? Now, for learning what Pythagoras theorem is, many of you might already know what Pythagoras theorem is, but let's refresh our memory. Pythagoras theorem, before starting with the definition, I want to explain that for Pythagoras theorem, we need a right angle triangle. Now, what is a right angle triangle? A triangle which has one angle as 90 degree is called a right angle triangle. Now, as you can see, this is a right angle triangle because one of the angles, how many angles does the triangle have? 1, 2, and 3. So it has 3 angles, right? Now one of the angles is 90 degrees, so this is a right angle triangle. Now in this right angle triangle, as you can see, the longest side is called the hypotenuse, this side is called the base, and this side is called the perpendicular, right? Now these two sides are interchangeable depending on the angle that we consider, right? Anyway, this is a right angle triangle, and in this right angle triangle we have hypotenuse, which is the longest side, then we have base, and we have perpendicular or height, right? Now keeping this in mind, let's see what the Pythagoras theorem, what Pythagoras tells us. Pythagoras theorem tells us that hypotenuse square is equal to height square plus base square. That means this hypotenuse, this side square, is equal to this side square plus this side square, okay? That is what the Pythagoras theorem tells us. That is hypotenuse square is equal to height square plus base square, right? Now, let us consider a right angle triangle which has this point as A, this vertex. What is this edge and this edge and this edge called? These three edges are called the vertex of the triangle, right? The vertices of the triangle. So let's name this vertex A, this vertex B, and this vertex C, okay? So it will be easier for us. We can say that AC is the hypotenuse, BC is the base, and AB is the height, right? So let us see. Hypotenuse square is equal to height square plus base square according to the Pythagoras theorem. So hypotenuse is AC, so AC square. Height is AB, so AB square, and base is BC, so BC square, right? Now AC, we need hypotenuse only, so let's remove the square. We put AC here, and when square goes to the other side of equal to, it becomes square root, right? Or in other words, we have, in order to remove the square, we take square root on both sides, right? So AC, square goes to the other side, becomes square root. Then now we have got the hypotenuse, which is AC. AC is equal to root of AB square plus BC square. Root of AB square plus BC square. So we know that hypotenuse of any given right angle triangle is the root of the perpendicular square plus the base square. So this is what we have to remember and keep in mind as we are going to proceed and see how to represent an irrational number on a number line. Okay, so let us proceed. Now let us take the first irrational number that we know. It is root 2, common irrational number that we know, right? So now let us try to represent root 2 on a number line. Now as you can see, this is a number line. Now the first number that we are going to represent on the number line is root 2. Now as you can see, please look at the number inside the root. The number inside the root is 2, right? Now 2 can be split into 1 and 1, and we can add them in order to get 2, right? So that means 2 can be written as 1 plus 1, right? Now let us take the square root of the first number. The first number is 1. So we're going to find the square root of 1, okay? And we are going to take the square of that square root. So what did we do? First we took the first number, right? We found the root of that number, and we took the square root of that number, right? And we took the square of that number, right? So what did we do again? We took the first number, we took the square root of that number, and we took the square of that number, right? And what did we get? Root 1 square, as it is clearly, we know that it is 1, right? Now we take the second number and repeat the same process. What is the process? We first take the square root and then we take the square of this number, right? But here we don't need to repeat that process. Why? Because both the numbers are 1 and 1. Both the numbers are 1, right? So we don't have to repeat that process. Now, why did we do this? We did this because this 1 is the unit of the line that we need to draw, okay, from 0, okay? This number is the unit or the measurement of the line that we need to draw from 0, okay? So what do you see here? We have 1. So what do we take? We draw a 1 unit line on the number line starting from 0, okay? Another line of 1 unit is drawn here from 1, okay? Another line is drawn of 1 unit from 1, okay? So what did we do here? First we drew a 1 unit line from 0, and then the point where that line stops, we drew another 1 unit line perpendicular to that line. Perpendicular means at 90-degree angle, right? And why did we draw this? Because we are going to make it into a right angle triangle, okay? That is the reason why we took this. So 1 unit, again 1 unit. And why did we take 1 unit? Because when we found the square root and the square, when we took the numbers, we got 1 in the previous part of the video, right? So this is also 1 unit and this is also 1 unit. Now the second step is to make another line to join this point and to join this point. once we joined, we can clearly see that we have a right angle triangle here, right? Now in this right angle triangle, we have one here and one here. Now we need to find out what is the length of this hypotenuse, right? Now we are going to use the Pythagoras theorem that we learned in order to find out the length of the hypotenuse, okay? So let us find out. So here, as you can see, the base is 1 and the perpendicular height is 1. So in the formula that we have learned before, which was hypotenuse is equal to root of perpendicular square plus base square, we substituted the values. That is, perpendicular is 1, so 1 square, and base is also 1, so 1 square, right? Now let us solve this. Now as we know, root will remain root itself. 1 square is 1. Again 1 square is 1. And now this 1 plus 1 will become 2. So we get root 2, right? So that means the hypotenuse is root 2. So let's see. Hypotenuse is root 2, right? So we have root 2 as the hypotenuse, as you can see. Now we have root 2 here. This is root 2. But where do we actually need root 2? We need to find root 2, or we need to plot root 2 on the number line, right? Likewise, here we have 1 on the number line, 2 on the number line, 3 on the number line, right? So likewise, we need to plot root 2 also on the number line. So what do? We have to take a geometry box and we have to take the compass out of the geometry box. We are going to use the compass in order to plot root 2. Okay, so let's see the procedure. Now we have to take the compass and we have to keep the pointed part of the compass on 0. Okay, and we have to take the pencil and we have to keep it on the pointed part or the vertex of the triangle. Okay, so that means we have got the length root 2 on the compass, right? After taking the length root 2 and after making sure that your compass is stiffly pointed and kept at this point, which is 0, we are going to make an arc. Okay, we are going to make an arc. So what do? We have to hold this part of the compass. Sorry, we have to hold this part of the protractor and we have to make an arc here. Okay, with which measurement? With this measurement. So let us look at how we make the arc. So we have used the compass and we have made an arc here, right? So now let us look at how the arc looks like. So this is the arc that we made using the compass. Okay, so what did we do? First we kept it here and then we kept the pencil point here and we kept this point stiff and moved the compass in order to find this arc, right? As you have seen, right? So let's look at it once more. That is the path which the arc was drawn in, right? Now this arc touches the number line at this point. As you can see, this arc touches the number line at this point, right? The point where the red marker is right now, right? So this is the point at which the arc touches the number line. So this point is root 2, okay? This point is root 2. Since this point is 1 and this point is 2 and this point is 3 and all of these distances are from 0, likewise this point that we have got right now is root 2 since the arc touches the number line at this point. Okay, so now we have got the distance which is root 2. So let us look at root 2. So the line that I have drawn in pink here is the distance from 0 to root 2. So as you can see, this is root 2. And now what have we done? We have plotted root 2 on the number line. So as you can see, like 0, 1, 2, 3, minus 1, minus 2, etc. all numbers which we have plotted on the number line earlier. Likewise, root 2 is also now on the number line. Okay. So now let us look at another number, how to plot another number on the rational on the number line so that it will be clear. Okay. Let us take the next irrational number. The next irrational number is root 3. Let us look at how to plot root 3. We are going to follow the same steps. Okay. So first, We look at the number which is inside the root. Here it is 3, and 3 can be written as 2 plus 1. As you know, 2 is the previous number. So when we take 3, I'm going to take 2 plus 1. When I take 4, I'm going to take 3 plus 1. When I take 5, I'm going to take 4 plus 1, right? So that is the sequence that we need to repeat, okay? So keeping that in mind, first look at the number inside the root. The number is 3. Then I split the number 3 into two parts. First is 2 and then 1. So 2 plus 1 is 3, right? Now what do? I take the square root of this first number, which is root 2, and then I take the square root of this second number, which is root 1, right? And then I plot these two numbers and I take the lines of height with measurement this and this, right? Let me look at it. First of all, I take a line with height or with measurement root 2, a line with length root 2 units, right? The next, I draw another line with measurement root 1 unit, right? So I draw another line with measurement root 1 unit. Now you must be wondering why I didn't put root here, because root 1 is 1 itself, right? So therefore 1 unit or root 1 unit. So as you can see, first I got two numbers when I split 3, then I took the square roots of those two numbers, then I took lines with these measurements. Root 2 line is here and root 1 line is here. So I took two lines. Now since I got two lines, these are two parts of the right angle triangle. So therefore I can join these two lines and form the third side, which is hypotenuse. So let's see. So I join that and I find that I've got a right angle triangle. Now in this right angle triangle, I need to find the length of the hypotenuse in order to proceed. So let's use the Pythagoras theorem. As you know, Pythagoras theorem tells us that hypotenuse square is perpendicular square plus base square. So what is the perpendicular? Perpendicular square plus base square. So I put root 2 in place of base and 1 in place of perpendicular. So I substitute the values. Now root 2 square is 2 and 1 square is 1. We know all those, right? Now 2 plus 1, I'll get 3. So my answer is root 3. So that means my hypotenuse is root 3. So that means this hypotenuse is root 3, right? So now after getting all the three sides, which is root 2 I had from before, 1 I had from before, and right now using Pythagoras theorem I found out the third side, which is hypotenuse, which is root 3, right? After all these process, I take the compass and I keep the pointed point here and I keep the pencil here and I press here and I form an arc here. I have to form an arc here, just like we did in the previous question, right? So let's see the procedure. So now I have got an arc. Let's look at the arc that has formed. So this is the arc that I formed right now using the compass, right? So let's trace the path of this arc. This is the path that I traced in order to find the arc, right? That is the path that I used from the compass in order to find the arc, right? So now I've got an arc. Now, as we have seen in the previous question also, the point where the arc meets the line will be the root 3, the question that we were searching for, right? So now the point that the arc touches the line is this point, the red point, as you can see, the highlighter point. So we are going to mark this entire distance as root 3, okay? So let's see. So this is root 3. Since the arc touched the number line at this point, we know that this line is going to be of root 3 unit measurement, right? So therefore now we have plotted root 3 on the number line, right? Now let's look at another example. root 5. What do? Let's revise. The first thing to do is to look inside the root. What is the number inside the root? It's 5, right? Then I take 5 and split it into two parts. Since I'm taking the number 5, I know that I need to split it into two parts in such a way that the one part should be 4, right? When I take 3, it should be 2. When I take 2, it should be 1. So likewise, when I take 5, it should be 4, right? Now if I take 6, what is the number? Can you guess? The number is definitely going to be 5, right? So likewise, this number 5, I'm going to split it into two parts. The two parts are 1 and 4, right? After splitting, what do? I take the first number and I take the square root of that number. Now where's the square root? I don't have to write the square root because square root of 1 is 1 itself, right? Now I take the second number, which is 4, and I find the square root again. So what is the square root of 4? I know that it is 2, right? So I have got two numbers, 1 and 2. Now I need to form lines with this measurement. So what are the lines? Let's look at the lines. I'm going to form one line which is of measurement 2. Okay, so I have formed one line which is of measurement 2. Then I form another line which is of measurement 1. Then I join these two lines, just the same procedure that we have repeated in the previous two questions. I join these two lines and I find the hypotenuse using the Pythagoras theorem. So what will be the hypotenuse? The hypotenuse will be root 5. Okay, the hypotenuse will be root 5. And after getting the hypotenuse, what do? I take the compass, I keep one point here and the pencil point here, and I make an arc, right? After making the arc, I know that the arc will touch this point on the number line. So this point is root 5, right? So this point is root 5, as you can see. So that means this blue line shows the distance or shows the length of root 5 from 0. So that means this is root 5. So therefore we have plotted the irrational number root 5 on the number line. So you can see that the steps remain the same and only the number changes. So you can find root 7, root 9, root 6, root 3, any number on the number line you can represent, right? So please try out one or two numbers by yourself also, okay?